Okay. So just in the previous video we have proved that the wave function satisfies Bloch theorem. Now let us consider H is the Hamiltonian. If xi k of r is the crystal wave function, then as you know it can be written as Hamiltonian H operated with xi k of r is equal to E into xi k of r. Now what we do is this crystal Hamiltonian may be written as sum of the Hamiltonian for free electron. That means what? Let us consider total Hamiltonian H is composed of two parts, that is H0 and H1. What is H0? Just you have to recall the Schrodinger's equation. H0 is nothing but minus h cut square 8 pi square m into del square plus, actually total Hamiltonian means minus h cut square by 8 pi square m del square plus V of R, potential energy, right? Kinetic energy plus potential energy. That one I am changing, just plus V naught of R minus Rn, and H1 is equal to V of R minus V naught of R minus Rn. When you add these two get cancelled. Equation get balanced. What is this V naught of R minus Rn? It is nothing but potential, right? It is nothing but potential due to, I am writing V naught means due to nth ground state atom on electron at a distance r. That means you have to consider the nth atom which is in the ground state. Okay. Now what is the value of electron potential because of the influence of nth ground state atom? That we have indicated as V naught of R minus Rn. The energy of the electron in the crystal is obtained by evaluating the expectation value, because average energy of the electron we have to consider, because there are n number of electrons. Therefore we have to consider the energies of different electrons and you have to get the average value. So in quantum mechanics, to get the average value, what we are doing? We are doing the expectation value. So that is nothing but, as you know, expectation value is nothing but what? Anything. Expectation value of is nothing but, this is xi star x xi, right, divided by integration xi star xi, right, into dx. This is the basic equation. So here I am representing xi k star of r, right, of Hamiltonian H of xi k of r dr divided by integration xi k star of r xi k r into dr. It is the complex conjugate of this. Then what is in the denominator, right? As you know, average energy is equal to energy of total energy of all n electrons, right, divided by total number of electrons. So this is our ordinary language we are writing, right? That means what? The denominator indicates the total number of electrons under consideration. Therefore I have substituted that one as n. In the next step, just there is no need to write every time, just E of k you can write. In the next step, what you have to do is you have to substitute the value for H0 and H1. Already we have written for that. Therefore, E of K is equal to 1 by N integration 1 by 1, separate two terms you write, one term for H0, another term for H1 in the single step itself. Xi K star of R into H0. H0 is nothing but minus H cut square divided by 8 pi square M into del square plus V0 of R minus Rn Xi K of R into dr, right, plus second term 1 by N into Xi K star of R into V of R minus V0 of R minus Rn into Xi K of R into dr. So now this is equal to what is this? Minus H cut square by 8 pi square M del square plus V0 of R minus Rn means this is nothing but the total energy of the electron. I can take that one as E0. E0 divided by N. Remaining term is what? Xi K star R, Xi K of R into dr. What is that? It is similar to this denominator. That means that is equal to N plus 1 by N. Now I am substituting, expressing the wave functions. See, Xi K of R and Xi K star of R, they are the complex. Xi K star is nothing but complex conjugate of Xi K. That means what? For every electron, there exists another electron which has the wave function exactly opposite to this. That means what? If Xi is the wave function for one electron, there exists another electron whose wave function is complex conjugate of this, that is Xi star. Right. Therefore, what I am writing is, see, this, if I write Xi K of R as Xi naught of R minus Rn, okay, into e to the power Ik into Rn, right. But usually what we are expecting, Xi K star of R is equal to Xi naught into R minus Rn into e to the power minus Ik Rn we are expecting. But remember that an electron which is present in the crystal lattice whose wave function is complex conjugate of this, that is present at a distance R minus Rm. Not exactly, because at R minus Rn you have one particular electron, but its complex conjugate is present at some other distance. Therefore, I am changing Rn by Rm. Okay, hope that you have understood this. Okay, therefore substitute this. When you are multiplying these two, what happens? These two terms becomes e to the power Ik into Rn minus Rm. I am taking outside e to the power Ik into Rn minus Rm summation, right? Sorry, here for these two total summation n and m e to the power ik Rn minus Rm integration xi naught star of R minus Rm into V of R minus V naught of R minus Rn into xi naught of R minus Rn into dr. Okay. So here what happens? Consider this. This becomes E naught, n get cancelled, plus 1 by n into sigma m n e to the power ik into Rn minus Rm into integration xi naught star R minus Rm into V of R minus V naught of R minus Rn into xi naught of R minus Rn into dr. So this is the expression we have obtained here. Now how we can simplify further E of k? Right. For this, consider this expression. See, as for simplicity, what we do is we have considered there are n number of identical atoms, right? So we expect that every term in the summation from n is equal to 0 to n is equal to n minus 1, that is total n number of identical terms, right? In this expression there should be n identical terms corresponding to n number of atoms, in which n number of electrons under consideration. Remember, n is equal to 0 to, so therefore we have to expect every term in the summation should contain n identical terms starting from n is equal to 0 to n is equal to n minus 1. So by considering this, for simplest case is n is equal to 0, we can easily consider this. For this, what happens? We can write, if n is equal to 0, E of k is equal to E naught plus, see, here what happens? N is equal to 0 means what? So you are considering an electron which is present or an atom which is present at the origin. Distance is 0, right? So therefore e to the power only, therefore n is equal to 0, it goes, only m terms contains, right? E to the power minus ik into Rm. Integration xi naught star R minus Rm into V naught of R minus V naught of R minus, what you have? R minus Rn, that is 0, right? So, sorry, this V of R minus V naught of R into xi naught of what? Rn. This Rn is 0, distance is 0, therefore xi naught of R into dr. This is what you are getting, right? See, now consider here m varies, right? M varies from what? 0, 1, 2, 3, etc. Again you consider, for simplicity, m is equal to 0. For m is equal to 0, what we can write? If m is equal to 0, Rm is 0. E to the power 0 is 1. What else the remaining terms? Xi naught star R minus Rm, right? Rm is 0. Xi naught star, this V of R minus V naught of R, xi naught of R into dr. let us you take this one as minus alpha. Okay. So now next thing is, if you consider the nearest neighbors other than 0, right? What we can write this expression as xi naught star of r into v of r minus v naught of r into xi naught of r dr. This can be taken as a minus beta. Okay. So that means this is for m is equal to 0, this is for nearest neighbor. But you have to consider that, use this equation, E of k is equal to, now E naught, first for what you have to consider, n identical atoms, what you are getting, this, correct? Xi naught star, this, these are all the terms you are getting. Now we are considering that there are spherical symmetry we are considering. Okay. So what happens here? See, E naught. Next, for m is equal to 0, the term comes is minus alpha. Then for rest of the terms, minus beta into this you have to consider, right? E to the power here minus ik into rm, right? This one you have to consider. So this is for n is equal to 0, means only one atom you are considering, right? Remember, same thing is applicable, one by one you are considering. Therefore we have made the statement, there are n identical terms. Okay, therefore if n is equal to 0 means you are considering one atom. For that you are considering, therefore n won't come here. Okay, so that is the expression. So that means only the thing is, for m is not equal to 0, you have to add this term. Okay, you have to add this term with the summation, m is equal to 1, 2, 3, etc. Okay, this is gives the total energy of the electron. So that means when electron is, when you consider an atom which is farther away, then its energy is E naught. Okay, its energy is E naught. But when you brought the atoms close together to form a crystal, the energy of the electron undergo variation. You will come to know, here we have taken minus. Don't think that the energy of the electron is decreased. No, you have to evaluate this equation in the next class. Okay, it may be, it will come plus when you consider this, or it may come minus. So when the electrons are interacting, what happens? Some electrons loses energy, some electrons gains the energy. Because of that, we are getting the energy bands. So further discussion about this equation is in the next class. Thank you.